Okay, so second video, we're on page 7 in the Bahamian Landscapes textbook, okay? We got figure 1.6 and below figure 1.7, right? So we're just going to look at the actual formation of the Bahamas, and it's the Bahamian shelf is what we call it, all right? Or Bahamian platform. So look, we've got lots of, Florida, Cuba, Hispaniola down here. We got our Bahamas in here, down to Caicos and Turks included down there, right? Atlantic Ocean out to the east. Now, the different shades of blue, the lightest blue is the shallowest water, deeper, and then the darkest blue is the deepest water. As you can see, closest to the islands and even Cuba and Florida and so on, we got very shallow water. Then we're all surrounded. Now, some of the islands have individual little bits. Okay, you can see Caicos, you can see around Crooked and the Acklands and so on. They've got their own little shelf here. Then we are all on this one big similar shelf. Okay, starts as a Blake Plateau and comes down around here. Okay, so you can see the way we're all then connected as you go down deeper under the oceans. All right, out to the Atlantic, then we're looking at a huge drop off. All right, and that's on a global scale. Now, there's two areas in particular you need to look at. These two large light blue areas here. You got the Great Bahama Bank and Little Bahama Bank. All right, now these combine a number of islands together. For example, Great Bahama Bank has Bimini, the Berries, Andros, New Providence, Eleuthera, Exuma, and so on. So this platform is all at a similar depth underwater, and then all of these islands sit on top of that shelf or platform. It's a little bit easier to see, in particular those two. Figure 1.7 on page 7. Alright, so the black is the ocean, green is obviously the land, and these red bits are the platforms, or the shells that we sit on. You can see the tongue of the ocean coming in here, alright, in between Nassau and Andros, or New Providence and Andros. Okay, but actually we're all connected on this shelf of land that sits just below the ocean. And then the islands are the pieces that stick out of the ocean, alright? So having said that, all the places in this area are very similar then. So the Bahamas is the same as Florida, as northern part of Cuba, not so much the south, and the Turks and Caicos and so on were all formed geologically in a similar fashion. Alright? So to continue on with that on page 9, alright, formation of the platform. Now this isn't necessarily just the Bahamas. The platform is that large area just below the surface on which sits a number of Bahamian islands. So one of the first things to realize is that geologically the Bahamas is related to its neighbors, Florida, Cuba, Turks and Caicos. Okay? This Blake platform or plateau to the north, that extends down past Florida down towards Cuba. Now the Turks and Caicos Islands are very much an extension of the southeastern Bahamas. Florida is very much like a large scale version of Andros. Alright? So the southern half of the Florida Keys is very similar to a place like Bimini and Exuma. Alright, the islands are formed in the same way, they've got similar depth of ocean and vegetation and all of that kind of thing. Okay, so they're all very similar in that vein. Bit of highlighting there, we're going to skip on to page 42 now. Alright, so on page 42 here now we have the first factor. I put number 1. So how did all this form, and how did this lead to the formation of our rocklands and wetlands and ridgelands? So what I've just done is highlight just fallen sea level during the ice ages. Okay, so it's been approximately about 2 million years since the ice ages began, the last ice age began. Alright, and during an ice age, during that time, there are periods of glaciation, alright, and periods called interglacial or interglacials. Now I've added a little note over here. Glacials are the cold periods, alright. Interglacials are the warmer periods of time. Alright. So in the interglacials were periods when the climate was probably very much like it is at the present time. Okay, so when we had our nice warm climate. During the glacial periods, it would have been considerably colder in this area. Alright. Now, what actually happens is during the glacials, as the periods of glaciation are called, alright, the cold snaps when there's more and more ice spreading. The situation in the northern latitudes, so higher towards the north and south pole, okay, they're very much like a bad winter which never ended. The effect of this, alright, didn't affect the Bahamas in terms of its climate. It was more of a change in sea level. Alright, so whilst the climate might have been a bit cooler, the big impact was a change in sea level. Okay, so when snow fell, or in the higher latitudes, it did not melt because we were in this cold glacial period. And it didn't melt means the water didn't return to the oceans. Instead, it accumulated or gathered in great ice caps and glaciers. Okay, as more and more of the world's water was transferred to land, the ocean levels then dropped. So whilst the water cycle would have continued, instead of water being returned back across the surface or through underground back to the oceans, it was held on land and stored as ice. Okay, think back to our topic on water we just finished. This interrupted or disrupted the natural water cycle, which meant that there was less water getting back to the oceans, and hence the ocean levels then fell. Okay, so sea level in the Bahamas fell by well over 120 meters. Okay, so again, that's a huge amount. Now that doesn't mean that everywhere in the Bahamas should be 120 meters above sea level. Okay, because obviously during the interglacial periods, that ice and snow would melt, returning large volumes back to the ocean, which is currently happening now. And that's one of the problems people talk about climate change. Alright, so this goes up and down all the time, but it certainly has had an overall effect on the formation of our islands. Alright, with falls of such magnitude, we can now imagine the Bahamian platform as a series of plateaus separated by deep channels, okay, like the tongue of the ocean. Okay, now we're going to look, you can add C figure 2, it's on the next page, or C figure 7, which we looked at earlier. Okay, jumping down to the bottom of page 42. So ridges. With the Bahamas now dry land, so the ocean levels have dropped. Okay, so now there's pieces, the islands have stuck out above the ocean level of the sea because the ocean level has dropped. Okay, several things happened that could not have happened before. So now that there's pieces sticking out of the ocean, things can start to form, landscapes can start to form. Again, the next thing is we're back to this prevailing wind. All right, if you're not sure what a prevailing wind is, these are winds, they are basically the result of, I don't want to go into that. For the Bahamas, they're easterly winds, okay? They blow from the northeast across the Atlantic Ocean. Prevailing wind is the most common wind in an area or place. So every country will have, or every area of the world will have a prevailing wind, all right? So what happens is, now you've got these bits of land sticking out of the ocean. Next thing is winds, okay? So they move any loose material in their path very much as they do in modern beaches or desert regions, all right? The most prominent, the most common sediment on these exposed pieces of land or banks was the oolite. It stood near the edge of banks and was higher than its surroundings, okay? So I'm going to just show you a diagram and take you through step by step to try and clear that up. Okay, so on page 43, we're on figure 4.2 now, okay? The description at the top is quite confusing, but if you look at the diagrams, okay? Before the ice ages, here's our shelf or our bank, okay? We got some reef, you got these sediments which are settled because we've got shallow oceans, okay? So you got oolite banks, let me just add, due to shallow oceans, okay? So that's where our oolites, for our oolitic limestone, start to settle, all right? Now, during the ice age, the sea levels drop, okay? So you can see it's dropped down. The reef is now exposed, and so is some of these sediments, all right? Enter the wind. So the wind blows anything across the corals from the edges, it blows it up onto the middle of the exposed land above sea level, okay? So you get some of these oolitic dunes, this material building up. All right. So again, during glaciation, the sea level falls even further. Okay, you can see the reef is completely exposed. This gives the time for this sediment to then layer up. Limestone crust is formed. So all that material is now layered up, and we have our limestone starting to form. Okay. Moving on to the last two stages then. The climate heats up, so you get an interglacial, a hot period. Okay, the sea levels rise up a little bit again because all that ice melts, returning water to the sea. The coral is now underwater, so it can start to grow again. Another little shallow ocean, new sediments form. Okay, this land is still above the sea. Then we go back. What happens again? Sea levels will drop a little bit. All right, you have your new reef formed, and more sediments blown across from the reef that's sticking out of the sea, blown over here, trapped by the old ridge, and new land forming. Okay, so it's just repeat, 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 repeat. Okay, so that's the steps, and then you just keep doing those steps. Hot, cold climate, sea level going up and down. Once the land or the sediments are exposed, the wind blows them onto where the land now is. They start to build up. Okay, so just to finish very quickly at the bottom, page 43, there are other reasons why the oolite was vulnerable to the wind. Okay, and these are important. So it was the finest and lightest material, so it was easy to blow around by the wind once it was above sea level. Grains are rounded and rolled over each other very easily, and there's no marine vegetation really to trap it, so it was moved around very, very quickly. Okay, so I'm going to stop there, and there's one more little video to go through.